Hello, I'm Alex Heneveld. I'll be giving a fairly different perspective on the whole issue. I'm CTO with Cloudsoft. We're a startup based out of Scotland, but we're a vendor, and mainly we sell and promote an open source product called DOXLON, which is part of Apache. It's around application management. We've done a lot of work managing Docker, but I think while the combinatorial explosion that Simon described has in some cases converged and quieted down. In other spaces, it's blowing up again. So that's sort of the focus of this talk. So I'll start by going through some of the deployment patterns. And one of the advantages of what we do is that we see a lot of different patterns in enterprises, in startups, in just old-fashioned small companies who've been making a living for a long time. And we'll present how Docker does give a lot of simplicity in a lot of cases. But then we'll show where the new complexity is emerging. And then I'll give an intro into DOXLON and our commercial product, AMP, the Application Management Platform, that tries to help give some tooling to give some simplicity around this complexity that's emerging. And there will be a demo at the end. So in the beginning, life was very simple. We would have applications which would run on machines somewhere. And then this cloud came along, and so now some of our applications run on machines and others run in a cloud. But then we needed to have more control about where things were running, so we started getting software-defined everything that might underpin cloud. It might underpin things that look like bare metal, and in some cases we wouldn't use it. We'd still have the real things that we plug into. So we start to get some complexity underpinning what we do. And this is where Docker starts to provide a level playing field. One of the great things about the Docker images format is that it gives you a very lightweight, portable way to have things running in lots of places, in dev, in production, in Amazon, in Azure, in the next big cloud. And if that's not simple enough for us, there's a lot of platforms as a service emerging on top of that, which make life even easier. We don't need to deal with 6 Docker images doing specialized roles, but the PaaS takes care of that even for us. And very often, applications do fit this model, and life is very nice and simple. And where it does fit, I'm a big fan of it. In reality, we find often applications increasingly don't fit this pattern. And PaaS is only one target that we can use. We might have a lot of NoSQL services that will also need some care and feeding. Analytics platforms as well that we need to look after, and our application will need some code to run within these analytics platforms, along with, of course, increasingly API management. A lot of the times we've got backend as a service and some API management, and the traditional 3-tier architecture is nowhere to be found. And of course, each of these things in the blue tier are going to sometimes have opinions about where they run best. A lot of them do run neatly in Docker, but as Simon said, sometimes they don't. Some people prefer LXC over Docker. I think we're going to see some exciting developments in the LXC world. But there are new containers coming along. We've done a lot of neat work with an Irish company called Weratech, who give you Java virtual machine containers, the same type of containerization, but it's higher up the stack, so there's sort of even less redundancy. And many of you have probably heard of Apache Mesos as well, which is kind of worth calling out. So although this combinatorial complexity started to converge to one with Docker, there's always innovation sitting on top of that, kind of new ways to deal with distributed applications, new fabrics that we want to run on. And so I'm pretty sure P does not equal NP. This combinatorial explosion is not going to go away anytime soon. Of course, when you build an application, it won't fit neatly into any of these boxes. Hopefully it will, but often it won't. And so an application may span a PaaS that runs nicely in Docker, but then there's an analytics component that has to run on bare metal, people say. Or more realistically, there may be an API management tier running in the cloud combined with a PaaS layer that may be sitting in Weratech because it's got a Java stack, and that's on bare metal because there's not a lot of benefit in putting virtualization underneath it, together with a NoSQL component that's also in bare metal, let's say for the sake of argument. So the deployment patterns are increasingly becoming more interesting. And it's into this fray that we think Brooklyn has a lot of benefits to bring. The aim of Brooklyn is to let you model applications fundamentally, describe them as blueprints so they can be deployed in lots of different places, but not just describe the initial deployment, but look after the ongoing modeling. And we'll talk a little bit more about what we mean by modeling. But the aim of monitoring it is not just so that we can know what happens, but so that the management logic can become part of that deployment. If we're living in or if we've got access to real-time componentry, actually part of the application logic is how are we going to use that? How are we going to respond to changes in demand or perhaps even failures? Recognizing that the human operator is an important part of that loop, but automation is also an important part of that loop. And that automation requires development, which we want to be able to bring the standard software engineering practices to. So kind of if DevOps means anything to me, it's about making sure that the dev guys and the ops guys are working together so that the new challenges we face in automating our deployments can be addressed with good software engineering discipline. At the start of this month, Brooklyn was accepted into the Apache incubator. So it is an Apache project which is safe to use. It's been Apache licensed for over 2 years. We've been developing it a bit longer than that. There is a commercial product, the one commercial slide that is in here. If you care about commercial support, that's available on top of Brooklyn through Cloudsoft AMP. But coming back to Brooklyn and Cloudsoft AMP, they're focused on giving you this model of the application. So one of our models earlier looked like this. It is going to run on some type of infrastructure, whether it's ours or someone else's. We've done a lot of work with a wide range of infrastructure providers. We're big contributors to Apache jclouds. We wrote the CloudStack driver, a lot of the OpenStack driver. It also gives you an abstraction that talks to AWS, Google Compute, SoftLayer. But it doesn't stop there. You can talk to addressable IP machines. So if you've got some bare metal that's been set up, an existing machine, most of our blueprints, when we can, we make them so that they can target localhost, just run over the loopback network. And of course, we've done a lot of work at modeling the network because increasingly application deployments are taking advantage of SDN. People are paranoid about security, and so rightly so in many cases. But in order for applications to respect the networking isolation and security, but also allow permitted traffic, it's more important than ever to have a model that understands at least the logical and the accessible components within a deployment. We've also done a lot of work with what we do on the box. We're fairly agnostic and pragmatic within Brooklyn. We don't want to boil the ocean. We want to give you this model that makes it easy to bring in the best of breed tools. So there's a lot of support for bash scripting, for chef recipes, for salt, as well as for pre-canned images. In general, we think of pre-canned images as an optimization layer, and Docker is sort of challenging that assumption. I think the jury's out on whether images will become the long-term solution or whether we're going to go back to a manifest that executes quickly. But certainly all of these have their places. As for what we deploy, we do a lot of work with putting agents on the box, not our agents, but whatever monitoring, collecting daemon you want on the box, collect D, for instance, talking to various monitoring stores, of which Graphite is a common popular choice. Log collection, as Simon said earlier, becomes very important in a disposable world. It's important in any case. Splunk does a great but expensive job. Logstash and Elasticsearch do a fantastic job and give you a bit more control over it. So all of these pieces become part of the blueprint which you want to lay down. Where Brooklyn sits is keeping track of this model in real time of the application. We know what we've laid down. We know the systems and how they're meant to communicate, and we know the monitoring pieces. So let's collect these, triangulate them, so that the application in real time shows us what's happening, and also provides a place that management logic can be attached. So if an anomaly gets detected, we can trigger an alert. or we can trigger an automated solution. Not just that we have to write those, but that we can tap into a library of best practice policies that get attached to various pieces within the blueprint or the application model. And I've talked a lot about the infrastructure pieces. We do a lot of work so that we can run in a lot of infrastructure, and a lot of the discrepancies go away or get handled appropriately, or at least give you the choices you need in the different environments. But one of the premises I opened with is that the future increasingly is moving up the stack, talking to various services. And so a lot of the focus in Brooklyn's model are locations which aren't infrastructure or cloud or bring your own node lists of IP addresses, but services. And so this kind of Franken app, which is actually going to become common apps, can describe a blueprint which consumes services on the one hand, requires provisioning of new services in the middle, and is a custom deployment at the left-hand side. All of that can quite nicely be accommodated within the blueprints. And you can get the same kind of policy-based management attached to it, together with the standard tooling where it's available. And one of the things I would caution, if you're looking at using services, make sure that you have the monitoring and the logging that you'll want from those services. Because I think a common problem that we see is that people start using services for the convenience, but then they don't have the visibility that they need that the operations folks really need to make sure it runs well. So I promised a very quick demo at the end. This is what Brooklyn looks like if you just download the stock application and run one of the examples. Resolution is very poor, but there's an Elastic Java Web DB sample which pops up in the catalog. This kind of is a facade of a nice GUI. It is a nice REST API with a fairly limited GUI that works really well as a debug console. It lets you see very deeply what's happening. But there are nice ways through a single curl you can deploy the blueprint of your choice. You can package it up and make it available to other people. So we deploy this blueprint, and the next choice point is to configure it. This is really very low resolution. Configuration is you can sort of set, in this blueprint, choose your WAR file, choose your database schema, job done. A common PaaS pattern. And in fact, this blueprint can run in lots of different PaaSes. It can also stand it up itself using your preferred app server, your preferred load balancer, cloud load balancers, Nginx. One of the fundamental ideas, of course, in bringing this OO approach to modeling is to allow substitutability. So different load balancers end up having a fairly similar signature. They have a common super interface or kind of a couple shared interfaces. And you pick your cloud. You can probably just about make this out. Say I'll run this in soft layer. And 10 minutes later, you'll have your application deployed. In this case, we've spun up a number of machines, which are shown as the leaf nodes. There's a JBoss server, an Nginx controller, and a MySQL database. But the JBoss server is part of a cluster, which in terms is which is kind of like an auto-scaling group. These are kind of some of the building blocks you can bring into your blueprints. And they're also extensible, but the nice thing is they're composable. So I say I want a cluster of JBoss, and that in turn is plugged into this load balanced cluster, and okay, the load balancer should be Nginx. And all of that together with the database should make up my application. In the middle, and again, you can't make it out, but various metrics are coming back. And since we're on the root of the application, these are the high-level aggregate sensors, kind of what you'd probably want the REST API to populate a dashboard. This is how the app is doing, 5 data points. But when you need to drill down and see what's happening on any given machine, what machines are we using at any point in time, the activity tab gives you a trace of every single atomic operation, whether it's a chef converge or a script run or a REST API call. And so that was a 3-tier app. What's the interesting work, and the reason that we're here talking about Docker, Docker is great to get started, but there's a lot of work if you want to manage a Docker infrastructure. So one of the open source projects that we're running is Brooklyn Docker. And Brooklyn Docker is aimed at providing this application management. Docker is an application, but providing a lot of the management that you want so that it runs as not just a single host, but a collection of hosts that can spin up on demand and can act as a target for deployment. Taking care of things like load balance and placement policies. Arguably, these are the things that the cloud platforms should be doing. Quite happy if they do it. But one of the virtues of Docker is, in fact, in contrast, it's meant to be very lightweight. So you actually want more like a lightweight application management framework rather than a heavy-duty cloud infrastructure. And so Brooklyn Docker is aiming to do that. And so in the case of Brooklyn Docker, you have the choice to roll out a basic Docker infrastructure. That's what this box here says, as I'm sure you can all make out. I choose the basic Docker infrastructure, and similar to before, I pick my environment. Let's run this in SoftLayer Dallas. Give it a name, choose the initial size, whether you want auto-scaling on or off. You hit go, and it's now provisioning, similar model, but a set of Docker hosts. And that comes up, and you've got the same sensors coming in. It's monitoring the hosts, giving you a sense of what containers are being used for what, all of which can be accessed through its REST API. And then the nice thing is, on top of that, of course, that Docker infrastructure becomes a location, which I can target or someone else can target as an endpoint. So this final slide has deployed our web cluster with the database from earlier into this Docker environment. And we've got the same sensors as coming before. The only difference, when we deployed this, it was a whole lot faster because we weren't waiting for any of the clouds to provision machines. And to confirm that the application is working, here's a sample screenshot. The stock demo, by default, does a hello world app, so you can say hello. So you're probably wondering, what do these blueprints look like? There's a Java underpinning, which gives you a very heavyweight, type-safe environment for doing all of your unit integration tests around the pieces that you want to be rock solid and reusable. On top of that, there's a YAML declarative syntax that's it's based on, it's compliant with the Oasis standard CAMP. There's work on Oasis Tosca, for those of you familiar with that. I'm on the TC of both of those. And the nice thing about this YAML description is that, of course, it is formal enough that a computer can understand it, which it has to be. But it's familiar enough that you can look at these. And yes, the next slide is a readable variant of this. I was hoping this would be the case. You can look at it and get a sense of what it's doing. Well, my web cluster has this web app cluster together with my database, and I've put in just a little bit of configuration. It's not a programming environment. There are just a couple of declarative hooks where you can do really just enough programming to express some of the common dependency injections, which is what we're doing in the middle, where we're leaning on a sensor with the URL of the database, which will be announced when it comes up, and putting that into the Java System Properties map. Under the cover, everything runs in parallel. The configuration stores the promise that this data should come in. It will block on it when it needs to, but really just in time. So you get kind of maximum parallelization. And the same thing that works for the pieces, the sort of building blocks of our topology, also applies to the policies. So I can refer to other blueprints or Java types for the policies and provide quite a lot of configuration to them. Another example is work we've done with Apache Cassandra and with the commercial data stacks, where you can very easily define the Cassandra cluster you want. This gets it running, whether in Docker or on a cloud or on IP addressable machines. But it also includes logic for how to deal with failover. And for those of you who've played around with Cassandra, you'll know that if a node goes down, it's not a lot of fun to try to bring up the replacement. We've done a lot of work to automate those processes so that you do get a best practice-based blueprint for Cassandra. It's work in progress. There's always more that could be done, but one of the rallying points and the reasons for going into Brooklyn is to put a community around this so that rather than everyone reinventing their own automation, there's a place where these can find a home and be shared. And of course, you can take this Cassandra cluster and combine it with a web app cluster and build a more interesting hybrid application and swap it over so you consume it as a service when you run in production, but when you run in dev, it's a single node environment on your local box. A handful of folks we're working with who are contributing blueprints and consuming blueprints. One of those companies is Weratech, who I mentioned earlier. Owe them a shout out because a lot of the Brooklyn Docker ideas actually originated from some Brooklyn Weratech work, where we're looking at the the same ideas around how do we deal with placement of containers across multiple hosts. It's a little higher up the stack, sitting at the JVM, but it's really the same idea. And what they have in common, I think, is that they're lightweight clouds that often is not you'll want to control or you'll be closer to the people controlling it than the idea of a cloud where it's a faceless service giving you things. And so finally, if you're interested in learning more, we're cloudsoftcorp.com, based up in Scotland. One or two guys down here and elsewhere, largely an open source company, startup and small. Most of our work goes straight into the Brooklyn.io or Apache Incubator Project Brooklyn. We are hiring, so if you're interested, please give me a shout out. I'm AH Tweeten on Twitter. And if you want to learn more about Docker, just search for Docker on our website or go to Brooklyn Docker under Cloudsoft at GitHub. Thank you.